Hey everyone, welcome back to another video on Maths A-Level 9709 past papers. Today we're going to talk about the Pure Maths 1 exam, variant 1-1 from the October-November 2024. So let's get into the paper. First question. In the expansion of kx plus 2 over x whole raised to power 4, where k is a positive constant, the term independent of x is equal to 150. Find the value of k and hence determine the coefficient of x squared in the expansion. Okay, so how do we search for this? So we know the general formula, for example, if we have x plus y raised to power n, so it's basically like every term will have nc, let's say k, x raised to power n minus k, and the second term y would be raised to k. And we basically have k going from 0 to n, right? So we need to figure out where kx and 2 over x are cancelling out each other. So such a power of x where this could happen. So let's see where this could happen. So let's form an equation independent of x. So you have kx, so general form of kx plus 2 over x raised to power 4 would be general form of the term would be 4c k and kx raised to power, no sorry, we already have k, so we need something else. Let's call it a. So a, and the other one is 2 over x, so let's call it 2x raised to power minus 1, 4 minus a. Or either way, it could go this way also. 4 minus a it is, and this is your a also. So this is the general form of the every term that we will see in this binomial expansion. So we need to know where x raised to power 4 minus a times by x raised to power minus a, when do they cancel out? So x raised to power 0. So the term independent of x would be this way. So yeah, so basically if you see this 4 minus 2a equal to 0, so minus a, basically simple, and a would be equal to 2. Okay, so 2a is equal to 4, a is equal to 2, so the term, corresponding term would be 4c 2 kx 4 minus 2, which is just 2, and 2 over x 2. So we can rewrite it as 4, so we need to write the coefficient properly also. That is 6, so 6 kx squared 2 over x 2. Okay, find the value of k, and okay, we need to, okay, so this is equal to 150. So we already know that x and x will term out, so x squared divided by x squared will cancel out. So you have 6 times by k squared times by 2 squared equals to 150. So therefore k squared is 150 divided by 6 divided by 4, so that is 25 over 4. So therefore k is plus minus 5 over 2. Now we need to see what is the condition on k, where k is a positive constant. So since k is greater than 0, that means k is positive 5 over 2. Okay, alright. Determine the coefficient of x squared in the expansion. Okay, so coefficient of x squared, we basically need to see which term would actually get us x squared. Again, so the general form for C, let's say A again, K 5 over 2 x raised to power 4 minus a, and the other one was 2 over x a. So we need to know where the coefficient of x is x2, so that would result in x4 minus a and times by x minus a. So we have to do the same thing again. So you have 2 this time equal to 4 minus 2a. So 2a equals to 4 minus 2, which is 2, so therefore a is 1. So this means that this would be for C1, 5 over 2x raised to power 4 minus 1 and the other one was 2 over x 1. So you see for C1 is 4 basically, 5 over 2 x cubed times by 2 over x. So 4 over 8, 2 cubed is 8, 5 cubed is 125, so 4 over 8 is 1 over 2. So, actually these two will cancel. 4 times by 2 divided by 8 will cancel out, so you have just 125 x squared. So the coefficient would be, therefore, coefficient of x squared is 125. So this time it's not coefficient, this was the term containing x squared, term corresponding to x squared. Okay, so yeah, that was the question. Let's move on to the next question. Question number 2. The curve y equals to x squared minus a over x has a stationary point at minus 3b. Find the values of constants a and b. Okay, so first off, what we can do is we can get an expression for dy by dx. So y is x squared minus a x raised to the power minus 1. So dy by dx would be 2x, and minus minus becomes plus a x raised to the power minus 2. So basically 2x plus a over x squared. Just to make sure we did the right thing, minus 1 comes down, plus it becomes positive, and the power on x reduced by 1 further. Okay. It has a stationary point at minus 3. So dy by dx at x is equal to minus 3 equal to 0. So therefore 2 minus 3 plus a over minus 3 whole squared is 0. So we have minus 6 equals to minus 3 whole squared becomes 9, and it goes on the other side. It's a over 9, minus minus cancelled. So a would become 6 times by 9, 54. Now we need to figure out what's b. So y at x is equal to minus 3 So this would be b equals to minus 3 whole squared minus 54 over x, which is minus 3. So this would become 9 plus 54 divided by 3, which is 18. So 9 plus 18, 27. And that's it for this question. Let's move on to the third one. Okay, so the diagram shows a sector of a circle center O, where OB is equal to OC is equal to 15 centimeter. The size of angle BOC is 2 by 3 radians, 2 by 5 pi radians. Points A and D on the lines OB and OC respectively are joined by an arc AD of a circle with center. Oh, okay, that's fine. The shaded region is bound by the arcs AD and BC and by straight lines AB and BC. Okay, it is given that the area of the shaded region is 2 over 9 over 5 pi centimeter cubed. Sorry, squared. Okay, my bad. Squared. Find the perimeter of the shaded region. Give your answer in terms of pi. Okay. So we basically need to work out two things. We need BC, we need AD arc length, we need AB, and we need DC. So we can find out the arc length BC first. This is going to be r theta, so 15 times by 2 by 5 pi, so 5 times by 3, so 6 pi centimeter. We don't know AD yet, but we can figure out the area of sector. Area of sector OBC, half r squared theta. So this is going to be half r squared, and theta is 2 over 5 pi. So we need to keep it clean. Let's use the exact values for while. Okay, so you have 0.5 times by 15 squared times by 2 pi divided by 5. No, sorry, 0.5. 45 pi. Right. So 2 gets cancelled. You have 5 times by wait. How? 2 and 2 get cancelled. 5 times by 3 is 15. 3 times by 5, or 15, okay, it's 45. Okay, alright. Now, area of sector OAD, area of sector OAD, which is going to be half OA whole squared times by pi, theta is 2 over 5 pi radians again. However, for sector OAD, we can use area of sector OBC minus the shaded region. So, area of sector OBC minus shaded region. So this would get us 45 pi minus shaded region is given as 209 over 5 pi. Okay, so as you can see, pi gets cancelled across the equation, this 5 can also be cancelled. Oh, no. This is not multiplied. Okay, so this 2, however, definitely it can be. So when you multiply 5 on both sides, you get 4 times by 5, 20, minus 209. So, oh no, wait. There is 45 pi. Sorry, this was 45 pi. 45 pi. Okay. So 45 times by 5 is 225. So 225 minus 209 is 16. So OA is going to be 4. Obviously, we can't have a negative length, so we will discard the negative choice. Right, okay. So what do we do further now? Now that we know OA, OD is also 4. Now we need arc length AD. Arc length AD is going to be r theta, so 4 times by theta, which is 2 over 5 pi. So 8 over 5 pi. We also need the length AB. So OD is equal to OA. And AD also we need. Okay, so we need now AB. AB is going to be 15 minus OA, which is 4, so 11. And DC is also 11. So DC is equal to AB, also 11 centimeter. So finally, perimeter would be AB plus DC plus arc length AD plus, arc AD plus arc BC. Arc BC. So you have 11 plus 8 over 5 pi plus you have arc BC, which we found out to be 6 pi. So we have 22 plus 5, 8 pi plus 30 pi. So this would turn out to be 22 plus 38 pi over 5. This is your perimeter exact value. Give your answer in terms of pi, so this is indeed pi. So perimeter, therefore, is this. Okay, so this is this question. Let's move on to the next one. Show that the curve with the equation x squared minus 3xy minus 40 equal to 0 and the line with equation meet for all the values of constant k. So basically we can make subject y over here and plug in y over here. Basically we need to show that simultaneous equation for this is going to be applicable or satisfied for all values of k, all real values of k. So 3x plus y plus k equal to 0, so therefore y becomes minus 3x minus k, so therefore plugging in the other one. So x squared minus 3x minus 3x minus k, a minus 40 equal to 0. You get x squared plus 9x squared and plus 3xk minus 40 equal to 0. Okay, so this has become sort of quadratic equation where this can further be simplified to 10x squared plus 3kx minus 40 equal to 0. So we can find out now, since this is meeting for all values of k, let's use the b squared minus 4ac. So b squared minus 4ac is going to be 3k whole squared minus 4 times by 10 minus 40. So this is 9k squared. Minus 40 times 1 minus 40 is 1600. So, okay, alright. So basically you see this over here. We don't know what b squared minus 4ac was, but you see this over here. This is a square form. This is a squared. This is a squared form. Basically 9k squared plus 16. So basically if you think about it, this is the minimum point, like the minimum value at y equals to 1600. For this, like for example, if you had y equals to 9x squared plus 1600, so this is you can say an easy square to make. So that means it's always, this particular quadratic equation is always greater than 0. So you can see that 9k squared would be greater than 0, right? Because 9k, like for example, if you start with x squared, it basically starts from origin. So 9x squared would basically have the same feature, just a little bit stretched. So 9k squared plus 1600 would be greater than 1600, or sorry, greater than equal to, my bad, greater than equal to 1600. So that's what we need. Do we have k for all the values of the constant k? Yeah, so basically this is yeah. That's it. Alright. Even if you write this as greater than 0 or greater than equal to 0, that would be fine. So therefore b squared minus 4ac is greater than 0. So because it's always starting at 1600, greater than 1600, so definitely greater than 0. So therefore it exists. So the equation, the curves and the line meet for all values of k. So curve and line meet for all values of k. Right. Okay. So that was this question. Let's move on to the question number 5. The equation of a curve is such that dy by dx is equal to 4x minus 3 root x plus 1. Find the x coordinate of the point on the curve at which the gradient is 11/2. So basically the gradient would be equal to dy by dx. So dy by dx, we need to figure out where 4x minus 3 root x plus 1 is 11/2. So this is 1. Okay. What can we do now? Right, so 1 goes on the other side, so this will become 4x minus 3 root x equals to 11 over 2 minus 1, that is 9 over 2. So we can do two things now. We can multiply both sides by 2 root x. So 4x minus 3 root x equals to 2 root x 9 over 2. Actually, this won't do anything. Okay, alright, so basically what you can do is we can treat this root x as, let's say, for some a is equal to root x, so therefore a squared would be x. So multiply by 2 at least we can do. So therefore this equation can be written as 4a squared minus 3a equals to 9 over 2. This can be further transformed into 8a squared minus 6a minus 9 equal to 0. So what we can do now is this is a quadratic equation. So let's do the sum and product rule. 8a squared minus 9 minus 6a. So a. We need 8 and we need 6. So 3. 2 times by, yeah, alright. So 12a and 6a. So that means 12 has to be negative. So you have 2a minus 3 and 4a plus 3 equal to 0. So you have either 2a equals to 3 or 4a equals to minus 3. A is basically root x. So you have right, okay. A is either 3 over 2, which means that root x is either 3 over 2, or you have a is equal to negative 3 over 4, which means that root x is negative 3 over 4. So there are no values, so this would be cancelled out, because root x function never goes below 0. So this is this, so therefore x would be 9 over 4. Okay, alright. Question part B. Given that the curve passes through the point 4, 11, find the equation of the curve. Okay, so basically we need to integrate that dy by dx, which is 4x minus 3 root x, so this is 1 over 2 minus 1 dx. Was it minus 1 or plus 1? Plus 1. Okay, so we have y equals to 4x squared over 2 minus 3x. 1 over 2 plus 1 is 3 by 2 divided by 3 over 2 plus x plus c. So this becomes 2x squared, and the 3 by 3 gets cancelled, so you're left with 2x 3 by 2 plus x plus c. So this is our general form. We need to plug in for 11. So x is equal to 4, y equals to 11. So y equals to 11, 2, 4 squared minus 2, 4, 3 by 2 plus 4 plus c. So 4 squared is 16, 16 times by 2 is 32. 4 square root is 2, 2 cubed is 8, 8 times by 2, 16, plus 4 plus c. 32 minus 16 is 16. 16 plus 4 is 20. So 11 equals to 20 plus c. So therefore c is 11 minus 20 minus 9. So therefore the function would be y equals to 2x squared minus 2x 3 by 2 plus x minus 9. Straightforward. And that's it for this question. Let's move on to the next one. Circles C1 and C2 have equations. These two, okay, so these two are different in different forms. This is the squared form, this is the expanded form. Find the different distance between the centers of the circles. Okay, so first off we need to make it this into squared form to find out the center of the circle, C1. So you have C1 x squared plus y squared plus, actually wait, this is 6x right, 6x plus y squared minus 10y equals to minus 18. So these are the squares that we need to complete. So what do we do? That, so completing the square method. So 6 divided by 2 is 3. So plus 3 squared minus 3 squared. So this is 1 squared plus y squared minus 10y. 10 divided by 2 is 5. So 5 squared minus 5 squared. Squared complete equals to minus 18. So you have x plus 3 whole squared and plus y minus 5 whole squared and minus 18 plus 9 plus 25. So 25 plus 9 minus 18 is 16. So you have C1 to be x plus 3 whole squared plus y minus 5 whole squared. So center of C1 is minus 3, 5, radius 16, center of C2 is 9, minus 4, and radius is 64, so that would be 8. No, sorry, this radius is 4, sorry. This radius is 4 because this is r squared. Okay, and for this one this would be 8. Okay, we need the distance between the centers. So distance between centers is equal to x minus x2 minus x1 and y2 minus y1 whole squared whole under root. So we get 9 plus 3, 12 squared is 144, and minus 4 minus 5 is minus 9 whole squared, which is 81. 144 plus 81, 50. That's it. Okay. P and Q are points on C1 and C2 respectively. The distance between P and Q is denoted by D. Find the greatest and least possible distances of D. Okay, so find the greatest and least possible values of D. Okay, so that could only be the case if we are talking about, for example, these two. So this is the line joining the two centers. So if we connect the farthest points from each other, this would be the farthest distance. And if we connect the like the closest ones, this would get us the minimum distance. So that's what we just simply have to do. So greatest value would be distance plus radius this, radius that. So 15 plus 4 plus 8, 15 plus 12 is either 27, and the minimum value, the least value is going to be opposite. So 15 minus 4 minus 8, 15 minus 12 is 3. So this was a no-brainer, and I think that's it for this question. Let's move on to question number 7. Question number 7. The diagram shows part of the curve with equation y equals to 12 over 2x plus 1 whole cube root. The point A on the curve has coordinates 7 over 2, 6. Find the equation of the tangent to the curve at A. Give your answer in the form mx plus c. So first thing we have to do is to differentiate this. So y is 12, 2x plus 1 minus 1 over 3. So dy by dx. So we will have to use the chain rule also. So first off, we bring the power down. 12 times by minus 1 over 3 times by 2x plus 1, and minus 1 over 3 minus 1 is minus 4 over 3, times by the derivative of 2x plus 1, which is 2. So 24 divided by 3 is 8, and there's a minus sign also, so minus 8. 2x plus 1 minus 4 over 3. Okay, so we need the gradient at A, 7 over 2. So this will be minus 8. 2 times by 7 over 2 is just 7 plus 1 minus 4 over 3. So this is minus 8. 8, 4 over 3, minus 4 over 3. So 8 cubed is 2. 2 raised to the power 4 is 16. So this is minus 8 over 16. So basically minus 1 over 2. So this is your that. So now we need the equation of tangent. So equation of tangent is y minus y1. M we already have, x minus x1. So y minus 6 minus 1 over 2. X minus 7 over 2. Right. So the right side becomes minus 1 over 2x plus 7 over 4. And we need this in y is equal to mx plus c, so we need to take 6 on the other side. So this would be 7 divided by 4 plus 6, 31 over 4. So minus 1 over 2x plus 31 over 4. Okay, so that's the equation of the tangent at A. Okay. Find the area of the region bound by the curve between the lines x is equal to 0, 7 over 2, and y is equal to 0. So basically we need the area of the curve between 0 and 7 over 2 dx. So the curve is 12, 2x plus 1 minus 1 over 3 from 0 to 7 over 2 dx. So this time we will use the reverse chain rule. So 12 times by, first we will do plus 1. So this will become 2 over 3 minus 1 over 3 plus 1. 2 over 3 divided by 2 over 3. And we need to divide by the derivative of 2x plus 1, which is just 2. So, and from 0 to 7 over 2. Let's hope we did not miss anything out. So 12 divided by, so 3 goes on, 12 divided by 4 is 3. 3 gets cancelled out. Wait a second. 2, 3 goes on the numerator. Right, okay. 12 divided by 4 is 3, 3 times by 3 is 9. So basically what we have is 2 times by 2 times by 3. 2x plus 1, 2 over 3, 0 to 7 over 2. So basically this becomes 12 divided by 4 is 3, 3 times by 3 is 9, 2x plus 1, 0, 7 over 2. Now we need the integral itself. So 9. 2 times by 7 over 2. This is minus, 2 over 3 itself. So 7 over 2 times by 2 is just 7 plus 1. 2 over 3 minus 0 plus 1, 2 over 3. So 8 cube root is 2, 2 squared is 4, and this would be just 1. So 1 raised to the power anything is just 1. So 9 times by 3 is 27. Okay, so that's B. Right, I think that's it for this question. Okay, so let's move on to the next question. Question number 8. It is given that beta is an angle between 90 degrees and 180 degrees such that sine beta is equal to alpha. Express tan squared beta minus 3 sine beta cos beta in terms of A. Okay, so we know the ASTC rule or the cost rule over here. So if beta is an angle between this, so you have beta over here. So we know that this is ASTC. Right. Sine of beta is A. So 180 minus B. This is 180 minus beta. Right. Okay. Okay. All right. So if this is A, and now we need to figure out what is cos and tan. So what we can do over here is we need to use the relationship between cos and sine. So we will use sine squared theta plus cos squared theta equals to 1, and that tan theta is equal to sine theta over cos theta. I think that's what we have to do. Okay, let's first see whether we get it in terms of A or not. So sine theta we already have. So cos theta we need. So cos squared theta would be 1 minus A squared. So therefore cos theta would be 1 minus A squared. And since it is in the second quadrant, it has to be negative, right? Because the cosine is negative in the second quadrant. And the tan theta will also be negative, so we need to extrapolate tan theta now. So tan theta will now be a over 1 minus a squared negative. Okay, so that means the tan theta squared, I've been using the wrong thing. So theta cancel. We are going to convert this into beta. So beta and yeah, we already have that. Okay. This would be a squared over 1 minus a squared, and the minus will take care of itself. Okay, so now tan squared beta minus 3 sine of beta cos of beta will be a squared over 1 minus a squared minus 3a cos beta is 1 minus a squared plus, because it's minus. Okay, we need to figure this out. We need to make it a clean expression. I don't think there is anything more we can do over here. This is the simplified form. So this is the simplified form. Right, okay. Part B. Solve the equation sine squared theta plus 2 cos squared theta is equal to 4 sine theta for 0 to 360 degrees. Okay, so over here we need to convert this cos squared theta in terms of sine theta also, because we have sine powered 1 over here, so cos squared theta is basically 1 minus sine squared theta, so therefore this would turn into sine squared theta plus 2 minus 2 sine squared theta minus 4 sine theta minus 3 equal to 0. You have minus sine squared theta minus 4 sine theta. 2 minus 3 is minus 1, 0. This would turn out to be sine squared theta plus 4 sine theta plus 1 equal to 0. So temporarily what we can do is we can treat it like any quadratic equation. So you have product 1 x squared 4x. So is there any? No. This we need to get through the quadratic equation. So sine theta would be minus b plus minus b squared minus 4ac, so that is just 4 2a. So this is minus 4 plus minus square root of 12 over 2. So 12 is basically 3 times by 4, so 4 square root can be taken out. So plus minus 2 root 3 over 2, which can be further written as minus 2 plus minus root 3. So this is the sine theta. We need two values. Okay, so we will use two values, right? So first we will use sine theta is equal to minus 2 minus root 3, and sine theta is equal to minus 2 plus root 3. So that's what we will do over here. So sine inverse is equal to minus 2 minus root 3 this would, no wait, degrees. Right, so obviously this will not give us any solution because this has gone past -1. If we do plus, we get -15, minus 15.542. So remember, minus 15 means before 0. So we need 0 to 360. So we can see this in terms of graph also. So let me show you first in the graph. So sine theta graph is like this, and it goes beyond like this. So minus 15 is somewhere over here. Minus 15 is over here, so this graph would come right over here again. So one point would be exactly 360 degrees away, and the other one, we need to see where this goes. So for the other one, because sine is symmetric, the distance between this and 360 would be the same distance between 180 and this one. So the symmetry of the graph, we have to take care of that. So 15.542 plus 360. So 360 minus 15.542, 344, 458. And you see the distance would still be 15.542, so the other one would be 180 plus 15.542. So 180 plus, this would be 195. 5. Let's see this same thing with a cos diagram. So minus 15 means that this is currently minus 15.542 over here. So the same angle from 0 to 360 degrees. So one would be one rotation, exactly one rotation over here. So that means just this is like plus 360 this. And the other one would be right over here. Because of the symmetry of the sine, just like we have sine over here equals to sine over here. So, So this angle and this angle, the sine value of this and sine value of this would be the same. So this would be 195. From the graph, it's easier to see from the graph. Okay, alright, so that is question number 8. Now on to question number 9. The equation of a curve is this: find set of values of x for which y decreases as x increases. So basically we need to see where dy by dx is less than 0. So dy by dx is, derivative of 4 is 0, 5 plus 12x minus 3 times by 3, 9x squared. So we need to see where this is less than 0. So this becomes 9x squared minus 12x minus 5 is greater than 0. So we solve this quadratic equation to see where the values are. Right, okay. So sum of the roots is minus 12 minus b over a, alpha plus beta. So you can use that sum and product rule also. So sum of roots is minus b over a, and the product of roots is c over a. So this would be alpha plus beta is minus 12 already. So 12 over 9, which is 4 over 3. And the alpha beta itself is c over 5, c over a, which is minus 5 over 9. So this would be kind of difficult to see over here. So basically, obviously, we cannot do this with sum and product rule because the roots will not come out to be integers. So basically, we can solve this quadratic equation. So x would be minus b plus minus b squared minus 4ac, 4 times by 9, 36 times by 5, 4 times by 9 times by 5, minus minus would become plus 180 divided by 2 times by 9, 18. So you have 12 plus 144 plus 180 divided by 18, 5 over 3. One answer is 5 over 3. The other answer would be minus 1 over 3. So this is your minus 1 over 3 and this is your 5 over 3. So these are the critical values. So the solution for this would be, since we need area greater than 0, so either it's greater than this or less than this. So x less than minus 1 over 3 or greater than 5 over 3. Sorry. Greater than 5 over 3. Right. And okay, alright, let's see. It is given that y is equal to 9x plus k is a tangent to the curve. Find the value of the constant k. So we know that dy by dx at the point of the tangent would be 9. So we need to find out where dy by dx is 9. So the dy by dx formula that we figured out was 5 plus 12x minus 9x squared is equal to 9. So taking everything on one side, 9x squared minus 12x, and 9 minus 5 is 4 equal to 0. Now 9x squared and 4 are both squares of 3 and 2. So if we had 3 and 2, this would be, okay, we can see that. Right, okay. Sum and product. So 9x squared, 4 minus 12. So x, this is 3, 3, this is 2, 2. So 6x, 6x. Only possible if both are negative. So that means this is indeed a square of 3x and minus 2. So this would lead us to x is equal to 2 over 3. Now we need to figure out what the y value of the original curve was at this value. So 4 plus 5x (6x squared) minus 3x cubed. Just to make sure that this is correct. 6x squared, sorry. Yeah, okay, so 6x squared. Okay. So at x is equal to 2 over 3, y equals to 4 plus 5, 2 over 3, plus 6, 2 over 3 squared, minus 3, 2 over 3 cubed. So let's simplify this a bit. 4 plus 10 over 3 plus 6 times by 4 over 9 and minus 8 over 9. So you have 4 plus 10 divided by 3 plus 24 divided by 9 minus 8 divided by 9. So the value of y is 82 over 9. So therefore k is, we had 9x plus k is equal to y. So y minus 9x. So at this value 2 over 3, 82 over 9 minus 9, 2 over 3. So 82 divided by 9 minus 18 divided by 3 is 28 over 9. Okay, alright. Let's see the next question. Question number 10. An arithmetic progression has first term 5, the common difference d, second and fifth and 11th terms of the arithmetic progression in that order are first three terms of the geometric progression. D. Okay, find the value d. So this is easy. We know the arithmetic series. So for example, if we use different numerals for this. So if arithmetic progression is represented by un and geometric progression is represented by Tn. We don't need the exact terms for this, but however, a plus d times by n minus 1, and this is a r n minus 1. Okay, so for the we have second, fifth, and 11th. So u2 would be just simply 5 because 5 plus d. This is easy to figure out. You can use this entire formula for that also. Fifth would be, like you guessed, 5 plus 4d, and u11th would be 5 plus 10d. However, for geometric progression, that is Tn, this is T1, 5 plus d, T2 would be, which is equal to a, let's say a, so T1 is equal to a equals to 5 plus d, T2 is equal to AR, which is 5 plus 4D, and T3 is equal to A plus AR squared equals to 5 plus 10D. So we know for geometric expression, you have AR equals to AR squared over AR, you will get is equal to R. That means basically the second term over first term equals to third term over second term, that is also going to be equal to R. So that's what we have to do over here. So 5 plus 4D over 5 plus D equals to 5 plus 10D equals to 5 plus 4D. This transforms into 5 plus 4D whole squared equals to 5 plus D 5 plus 10d. Okay, so 5 plus 4d whole squared would be 25 plus 5 times by 4, 20, 20 times by 2, 40d plus 16d squared equals to 5 times by 5, 25, 50d, 5d, e plus 10d squared. Okay, we now need to bring everything on one side, but first we can make things simple for each other. So 16 minus 10d squared is 6d squared, and 40 minus 55 is minus 15d. So as you can see, this becomes a quadratic equation, which you can divide by 3 on both sides. You will get 2d squared minus 5d equal to 0. D can be factorized. 2d minus 5 equal to 0. So according to this, either d is equal to 0 or d is 5 over 2. Earlier above, they told us that d is greater than 0. So since d is greater than 0, therefore d is 5 over 2. Alright, okay, moving on. The sum of the first 77 terms of the arithmetic progression is denoted by S77. Sum of the first 10 terms of the geometric progression is denoted by G. Find the value of S77 minus G10. Okay, so we know Sn is n over 2, 2a plus n minus 1d, and the Gn formula is a 1 minus r n over 1 minus r. Right. Right. Okay. Yeah, that's correct. So S77 is 77 over 2. 2a is 2 times by 5, 10. Plus d is 76 times by, what did we find d to be? 5 over 2. Okay, and g of G10 would be first term a. First term a is going to be second term, right? So 7.5 basically. So 5 plus 5 over 2, 7.5, which is 15 over 2. So 15 over 2. And the common ratio, we need to figure out the common ratio R also. So that would be, let's figure this out. So 5 plus 4 times by 2.5 divided by 5 plus 2.5. So 2. So R is 2. So where R is 2. So that is 1 minus 2 raised to power 10 divided by 1 minus 2. Okay, so this is right. So 10 plus 76 times by 5 divided by 2. This times by 77 divided by 2. This is 7700. Now we need this. So 2 raised to power 10 is 1024. So 1 minus 1024 divided by minus 1 is just 1023. So 15 times by 1023 divided by 2. This is this particular value, 15345 divided by 2. Wait, is this correct? R raised to power 10. Wait. 151023. So 1 minus 1024 divided by minus 1. And the first term is 7.5. So we are correct, but let's do it this way. 75 times by minus 1023 divided by minus 1. Alright, okay. Alright, so S77, so this is 76.7672.5. Okay, alright, never mind. So 77 minus 76, 72.5. So 7700 minus answer is 55 over 2, or 27.5. Alright, so that's it for this question. Let's move on to the last question. Question number 11. Function f is defined by f of x, 3 plus 6x minus 2x squared for x, all real number set. express f of x in the form this. Alright, so basically we need to complete the square for this. So first off, we rearrange this. Minus 2x squared plus 6x plus 3. Take minus 2 out. This becomes x squared minus 3x plus 3. Yes, okay, alright. Now this is the square that we need to complete. So minus 2 x squared minus 3x plus 3 over 2 whole squared minus 3 over 2 whole squared plus 3. So you have minus 2 x minus 3 by 2 whole squared, and just calculate the minus 2 times by minus 9 divided by 4, that is 9 over 2. 9 over 2 plus 3, so 4.5, so 9 divided by 2 plus 3 is 15 over 2. So minus 2 x minus 3 by 2 whole squared plus 15 over 2. So that's it. Let's take the range of f. Range of f. So yeah, so this is basically like this, where this is the maximum point, because we know that when you have a negative sign in front of this or in front of the x squared coefficient, so that basically that means that it's inverted U shape. This is 15 over 2 y value and the x value is 3 by 2. So that means f of x is less than or equal to 15 over 2. Okay. Right. Graph of f of y is equal to f of x is transformed onto the graph of y is equal to h of x by a reflection in one of the axes followed by a translation. It is given that the graph of y equals to h of x has a minimum point at the origin. Okay, so basically originally we have this where you have a max point. To make it a minimum point, we have to reflect it in the y-axis, and then we need to move this translation, we need to translate this point, which is 3 by 2, 15 over 2, downwards to 0, comma 0. So that's what we have to do. We first have to do the reflection. Sorry, did I say y-axis first? No, sorry. We have to reflect it in the x-axis. So give the details of reflection. So reflection in x-axis to invert the function. So minus f of x. So f of x 2 minus f of x. Now we need to translate this function. Now 15 over, you have 0, 0 minus 3 by 2, 15 over 2. So you will get this same thing, basically minus 3 over 2, 15 over 2. Wait a second. 15 over 2 minus, 3 by 2. So however, the thing to note over here is that once you have inverted it, the minimum point, the max point turns into minimum point. So Previously we had 3 over 2, 15 over 2. This transforms into 3 over 2 minus 15 over 2. So instead of this thing, I think I made a mistake. Yeah, sorry. This would be this. So this would be minus 3 by 2 and 15 over 2. So minus 15 over 2. So this would go actually upwards. 0, 0 over here. Right. So translation would be by minus 3 by 2 and 15 over 2. You can actually do the calculation over here also. 0, 0 final minus initial. 3 by 2 minus 15 over 2. So this would give you 3 over 2 negative and 15 over 2 positive. Alright, okay. Function g is defined by g of x. 3 plus 6x minus 2x squared. Wait, what is the difference now? Okay, alright, same thing. For x less than equal to 0. Okay, sketch the graph of y is equal to gx. Explain why g is a 1, 1 function. You are not required to find the coordinates of any intersections with the axes. Right, okay. So, previously we had let's first make the x-axis. Now the graph that we had before was what was it? Minus 2 x minus 3 by 2 whole squared plus 15 over 2. So 3 over 2, 15 over 2 was the minimum point. Sorry, maximum point. So previously you had this, where this was this point, and we need x less than or equal to 0. So basically you can find out what the value right, okay, so this is your point. 3 over 2. So 3 over 2 and 15 over 2. Okay, so basically you can already see this over here that the graph is starting much before this. So this is where your y-axis is now, somewhere over here. Okay, so if you gently plug in x is equal to 0, you will get 3 over here. But you are not required to find the coordinates of any intersections with the axes, so however, basically we don't need to do that. So if you go less than or equal to 0, so basically we only need, so I'm just going to use a different color for this. We only need this part of the graph. So we can cancel out this part. Okay. Now there is no turning point in this. So the problem is only when you have a turning point. Okay. So one of one function means that for every value of x you have unique value in y. So in quadratic function that is not the case, because in multiple values of x you have same value of y at a times. So if you show this way, actually let's make it slightly better. This would be this way. So this is your g of x. This is your y-axis. This is your x-axis. So basically there is no turning point over here. So the explanation is that there is no turning point. So since there is no turning point, in G, every x value corresponds to a unique y value, making it a one-on-one function. That's it. Okay. Sketch the graph of y is equal to g inverse of x on your diagram. In C, find the expression for g inverse of x. You should label the two graphs in your diagram appropriately. Show any relevant mirror line. Okay, so we know how the graph actually would look like. So the mirror line would be y is equal to x. So this is your y equals to x mirror line, and it would be exactly same going on over here. So the graph would actually let's use blue this time. It would be crossing this over here, and it would be meeting somewhere over here. So somewhat like this. Yeah, so this is your g inverse of x. Just a little bit curve over here. Yeah, so this is your g inverse of x. So this point over here would correspond to this point, and there's an obvious intersecting point over here. Okay, we need the g inverse. Okay, we can only find the g inverse for a quadratic function with the help of completed square form. Otherwise, we cannot do that. So we have x minus 3 over 2 whole squared plus 15 over 2. Now, this is your y. You need to make x the subject. You make y minus 15 over 2 equals to minus 2 x minus 3 over 2 whole squared. So this 2 can go on the other side, so this would become half, actually minus half plus half. 15 over 2 minus y equals to x minus 3 over 2 whole squared. Now when we take the square root, you will get x minus 3 over 2 plus minus square root of 1 over 2, 15 over 2 minus y, and 3 over 2 goes on the other side. So x would be 3 over 2 plus minus 1 over 2, 15 over 2 minus y. Okay, now we need to figure out which one is the correct one. Is it going to be the negative, is it going to be the negative one or the plus one? That's what we have to figure out. So remember this, that the graph is actually going lower and lower. So this is 3 by 2 minus that. So x value, you see, so basically y value of this, this is now g inverse now. G inverse is going less than that. Furthermore, also that a fact that is very important in inverse function, the range and domain swap for that. So the range and domain basically for g of x, domain is x less than or equal to 0, and the range was y less than or equal to 3, because when you plug in x is equal to 0 over here, you can see that you will get 3. So basically what you will have for G inverse of X, domain will be X less than equal to 3. Range would be X less than equal to 0. So basically the G of inverse has to be less than equal to 0. So the range we already saw in the graph also. So this has to be minus 1. That's why. So finally G inverse of X equals to 3 by 2 minus. We can multiply the 1 over 2 inside. So you will have 15 over 4 minus X over 2. That's it. So if you start with X less X 3, so you see, let's see what we get. So 3 divided by 2 minus square root of 15 over 4 minus, now you see this domain is now less than equal to 3, so we start with 3 over 2, we should get 0. So that is the starting point. So that is your inverse function. And that's about it for this paper. This was a long one. Hope you enjoyed this. If you have any questions, doubts, or problems, feel free to reach out in the comments. I would love to hear some feedback also. If you think I wasn't able to explain a particular question properly, please reach out so I may be able to explain it again. And if you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. Meanwhile, take care. We will see you in the next video. Bye-bye.